It's another exciting day in Algebra 2. Today we are looking at more function transformations, and what we are going to focus on today are functions that don't start at the origin and the order in which we apply transformations. So two things we're going to look at today are functions with vertices, and so that is our quadratic and our absolute value functions. So when we have standard vertex form, it's very quickly to easily identify where your vertex is. You have H and K, H and K. But when I've started applying transformations and I have multipliers in there, and we are using the form A, B, C, and D in that order, the way that you can find the vertex without having to factor things out is by dividing C over B, and then D remains your y coordinate. Now remember, it's important to note that just like it's x minus h, this is bx minus c. So if this is a minus a value, your c is positive, and if this is plus a value, your c is negative. So before we get into the nitty-gritty with that, let's just look at what happens when we do transformations in different orders. So if I'm starting at the point 2, 4, and I'm going to apply it in this order first. I do a vertical dilation by 2. So that means that I'm going to double my y-coordinate. That puts me at the point 2, 8. I doubled the 4, the x stayed the same. Then I want to move to the right 2. That means I'm going to increase my x-coordinate by 1, and now I am at the point 3, 8. Then if I want to reflect over the y-axis, remember that changes your vertical. It's a vertical change. It's changing your y-coordinate, and it changes the sign of it. So this becomes 3, negative 8. Then when you have a horizontal dilation by 1/3, remember that is the opposite reciprocal. It's not opposite reciprocal, but reciprocal. So you are going to be tripling your x-coordinate. So remember, we do the reciprocal with our horizontal dilations. And then lastly, up 2. So this is going to increase my y-coordinate by 2, and there is my final destination, 9, negative 6. Now let's say I started at the same point, but I did the transformations in the reverse order. So I'm still starting at 2, 4, and I'm going up 2. That puts me at 2, 6. Then the horizontal dilation by 1/3, again doing the reciprocal, means I'm going to triple my x-coordinate. Now I'm at 6, 6. Reflecting over the x-axis again is going to change the sign of my y-coordinate. Going to the right one is going to increase my x-coordinate. And then a vertical dilation by 2 means I'm going to double my y-coordinate. And so this is where I end when I do the transformations in the reverse order. So what's really important as we're going through these types of problems is you do the transformations in the order that they're listed. And another good way to make sure you've done everything correctly is follow the vertex or one point and make sure it ends up where it's supposed to. So when we apply these to functions instead of points, remember the vertical stuff affects everything, as in you're going to have to distribute, and horizontal stuff only affects the x. So if I'm starting with this function, x squared minus 3, and I'm going to do these transformations to find g and the new vertex. Well, let's look here, x squared minus 3. That's my parent function that shifted down 3. So my vertex is starting at 0, negative 3. So as I go through and do each of these transformations, I want to track where my vertex moves to. So the first thing we're going to do is a vertical stretch by a factor of 2. So what that means is my vertex is going to move to 0, negative 6, because I'm doubling that y-coordinate. So when it comes to my function, vertical affects everything. I'm going to have to multiply my entire function by 2. So this becomes 2x squared minus 6. Now, does this track with where my vertex should end up? Yes, this is the quadratic parent function that has a vertical dilation by 2 and is shifted down 6. So my vertex would be at 0, 6. All right, the next thing we want to do is translate 5 units to the left. So that means my vertex is going to move to negative 5, negative 6. So here, that means in my x, I need to substitute x plus 5 for that shift to the left. And now looking at the function I've written, this is in vertex form. So if I have x plus 5, that means my h is negative 5, and I have minus 6 on the outside, so my k is negative 6. So here is my new vertex, and that means my new transformed function g of x is 2 times x plus 5 squared minus 6. Doing another one. This time it's with absolute value. I have the absolute value of x plus 10. So the vertex for this one is going to be at 0, 10, because I've taken my absolute value parent function and shifted it up 10. Now let's apply these different transformations. First, we want to do a horizontal stretch by a factor of 2. So remember, this means that whatever is going inside is going to be the reciprocal. But let's also think about what this means is happening to my x coordinates. I need to half it, but 0 divided by 2 is still 0. So my vertex is not going to move due to this transformation, but I still need to put it in my function. So it'll be 1/2 x plus 10 is where I'm starting. Okay. Then we want a translation 3 units up. Well, that means I'm going to move from 0, 10 to 0, 13. So taking what we've started with here, I'm going to add 3 on the outside. Now I'm at 1/2 x plus 13. Checking with my vertex, yes, this is going to have a vertex at 0, 13. Okay, and then the last thing we want to do is go 2 units to the right. So that means that my vertex needs to move to 2, 13. That is where I need to end. And in order to make that happen, what I'm going to need to do is replace x with x minus 2, because the minus 2 is what tells us we have a horizontal shift. Now, in doing so, that 1/2 is going to be distributed. So what we're going to have after we distribute is 1/2 x minus 1 plus 13. So the way that we can double check to make sure that this has moved our vertex to the correct location is by checking for the vertex. Now, we are no longer in standard vertex form. We are in this form. So to find my vertex, I'm going to need to do c divided by b for the x coordinate, and then we can just see the y coordinate where d is. So looking here, c is 1, and b is 1/2. 1 divided by 1/2 is 2. And my d coordinate is 13. So I know I am in the correct location. My vertex is at the right spot. So my new function g of x is absolute value of 1/2 x minus 1 plus 13. Okay. The way to get better at these is just to keep practicing. We have a new function. Again, we are not in vertex form. So to find where my vertex is starting, we are going to have to look here. C divided by b over d. And this time, because this is a positive 4, remember this form is bx minus c. Because that is plus, that tells me that c was negative, because minus a negative becomes positive. So negative 4 over 2 gives us negative 2 for our x coordinate, and we can see that our y coordinate is positive 2. So this is where our vertex is starting. Let's see what these different transformations are going to do to it. First, we want a horizontal shrink by 1/4. So what this means is I am going to divide my x coordinate by 4. Negative 2 divided by 4 is negative 1/2. We're not changing that y coordinate. And now let's think about what we have to do inside our function to make that happen. Remember, with horizontal dilations, you do the reciprocal. So instead of putting 1/4 inside my function, I'm going to do a multiplier of 4. And that is going to replace x. So I'm going to have 2 times 4x plus 4 squared plus 2. So once I do my distributing, I'm going to have 2 times 4x. That will give me 8x plus 4 squared plus 2. Now let's double check that we have moved this function to the correct spot. If I'm going to do b divided by c, c is still negative 4. Negative 4 divided by 8 is negative 1/2. My d value is still 2, so we're on the right track. Now I want to translate 3 units down. Well, that means my vertex is going to move to negative 1/2, negative 1. And in order to reflect that in my function, I'm going to subtract 3 on the outside, which moves me to 8x plus 4 squared minus 1. And then lastly, we want to move 2 units to the right. So that means in moving in the positive direction from negative 1/2, that is going to move me to positive 1/2 or 3 over 2, negative 1. That's where I want to end up in the end. So to reflect that within my function, moving to the right would be x minus 2. So what I'm going to do is replace x here with x minus 2, and I am going to have to distribute. So that's going to give me 8x minus 16 plus 4 inside my parentheses, which simplifies out when you combine the negative 16 and the 4 to minus 12. And now double checking that we have put our vertex in the right spot, c divided by b. C is 12 now. 12 divided by 8 is 1.5 or 3 over 2. My d value is still in the right spot. So we've moved our vertex correctly, and we can now say that g of x is 8x minus 12 squared minus 1. All right, on to D. We have another absolute value function, and we are not starting at the origin. So to figure out where our vertex is, we're going to do c divided by b. That's going to be 2 over 3, and our d value is 5. So that's where we're starting. If we want to do a vertical stretch by a factor of 2, that means I'm doubling my y-coordinate. So I'm going to move to 2/3 10. And in order to reflect that in my function, I'm going to have to multiply everything by 2. And what that's going to end up looking like is 2 times the absolute value of 3x minus 2 plus 10. So c divided by b is still 2/3, and then 10 is now our d value, so that matches with where our vertex moved. So vertical stretch is done. Now we want it to translate down 2 units, so that means we're going to move to 2/3 8. In order to do that in my function, we're going to subtract 2. So 2, absolute value, 3x minus 2 plus 8. C divided by b is still 2/3, and my d value is now 8, so we're on the right track. Now we want to shift 5 units to the right. So that means I'm going to take 2/3 and add 5. So 5 and 2/3 is where I want my x-coordinate. My y-coordinate's not going to change. And in order to do that, shifting right is x minus that value, and I'm going to replace x inside with that x minus 5. And I'm going to have to do my distributing. So that will give me 3x minus 15, and I still have the minus 2. So combining all of those terms, 3x minus 17 plus 8 on the outside, checking that my vertex is now in the correct place. 17 divided by 3 is 5 and 2/3. D is still 8, so we have done that correctly. The last thing we want to do is reflect across the x-axis. That means that your y-coordinate is going to change signs. And I'm running out of room, so I'm going to move this down here. My vertex should move to 5 and 2/3 negative 8. So in order to make that happen, we are going to multiply by negative, but we have to distribute it to the whole thing. And so what that looks like is minus 2, absolute value of 3x minus 17, minus 8. Checking that our vertex is still in the correct spot, 17 divided by 3 is still 5 and 2/3, and now I have negative 8 for my y-coordinate. So g of x is negative 2, absolute value of 3x minus 17, minus 8. Okay, I am limited to 15-minute videos, so I'm going to go ahead and cut this off and do part E in a separate video, so I'm not rushed.